In lesson 24, we're going to begin a short study of percents, and we're going to start in lesson 24 with very convenient numbers. Exercise 1 talks about Rob's fruit farm, which consists of 100 acres, very conveniently. And they're growing 3 different types of apples on that farm. On 25 acres, the farm grows Empire apples. McIntosh apples grow on 30% of the farm, and the remainder of the farm grows Fuji apples. So you're asked to shade in the grid to represent the portion of the farm each apple type occupies. We'll use a different color for each type of apple, and we need to create the key with these guidelines to represent how much of each type of apple there is. So our first type of apple was Empire, and our information tells us that 25 of the 100 acres is growing Empire apples. Our part to whole ratio then is 25 to 100. And since the word percent means out of 100, cent, C-E-N-T, is the root for 100, and per means out of. So 25 out of 100 would be 25%. And then we would need to choose a color, whatever color that is for you, and shade in. I've chosen yellow, and this is a 10 by 10 grid, which means that there are 100 little squares. So I'm going to shade 25 of my squares. I'm a little out of the line, sorry about that. I'm going to shade 25 of those little squares yellow. Next it says that McIntosh apples are grown on 30% of the farm, and the part to whole ratio of that would be 30 to 100. Since conveniently our farm has 100 acres on it, 30% would be 30 out of 100. For McIntosh, I think our 30% perhaps will make green. Should have made this yellow up here. So I'll come over to our grid, and I'm going to shade 30, or 3 lines, green. And then finally it says the remainder of the farm grows Fuji apples. We know that the farm has 100 acres, and we also know that 25 of them were used for Empire apples, and 30 of them were used for McIntosh apples. 25 plus 30 is 55, and there are 100 acres altogether. So if we subtract 55 from 100, we would find out the amount of the farm that Fuji apples are being grown on. And 100 minus 55 is 45. So 45 out of 100, that's our part to whole ratio, are Fuji apples. And I'll use pink for the Fuji apples. Again, we're doing 45. So I have 5 left over in this third line. I'll do that. And then I should have 4 full lines to make the 40. And there it is. In exercise 2, we have another 100 grid, a 10 by 10 grid, but inside each of the squares we have the decimal 1/100th. Remember, the first decimal position is tenths, the second decimal position is 100ths. So each of these numbers is 1/100th. Conveniently, that does represent how much each of these squares is in a 10 by 10 grid. So the shaded portion of this grid represents the portion of a granola bar that is still remaining. What percent does each square of this granola represent? Well, each one is 1/100th, and percent means out of 100, so 1% would mean one piece out of 100, which is what each of our little squares represents. What percent of the granola bar remains? Remember, in the question it says the shaded portion of the grid represents the portion remaining. So there are 10, 20, 30, 40, 50, 60, 70, 80 100ths that are remaining. That means the percent would be 80% of our granola bar that is still remaining. We could write this percent also as a decimal, which would be 80 100ths. We could also write it as a fraction, 80 100ths. And we could write each of those in a simplified version. The fraction we could write as 8/10ths. And if we're really good at simplifying, we could also write that as 4/5ths. All equivalent fractions. The 80 100ths as the decimal, we could also write as 8/10ths, since the 0 at the end of our decimal really doesn't change the value. So those are all a variety of different representations of the same number. In exercise 3, you're given some shading and you have to represent each one as a decimal, fraction, and percent. So in 3A, we have a darker shading and then a lighter shading. The representation of the darker shading would be 2 lines of 10 out of 100, which is 20%. Written as a decimal would be 20 100ths, and as a fraction is 20 100ths. Please notice that the pronunciation of the decimal and the pronunciation of the fraction are exactly the same. That's how you can write a fraction from a decimal. In picture B, they have 3 different options: a dark shading, a light shading, and the white. If I were to represent the dark shading, I could count. There are 5 lines of 5, and that would be 25%. 25% can also be written as 25 100ths as a fraction, which simplifies to 1/4 just in case we want to be really savvy about it. As a decimal, it would be 25 100ths. Finally, in picture C, we find that there are 48 squares that are shaded. So we'll write that as 48%. The decimal is 48 out of 100, or 48 100ths. And writing the fraction, 48 100ths, simplifies to 12 25ths. Exercise 4 gives us a table so that we can fill in the values. The percentage, 6%, would actually be 6 out of 100, or 6 100ths. That decimal, please be very careful. 6 100ths has to be with the 6 in the hundredths position, because the last digit in your percent must fall in the hundredths position of your decimal. Must fall there. Please keep that in mind. That means my 6, which is the only digit in our percentage, has to be in the hundredths position in the decimal. The fraction is 6 out of 100, 6 100ths. Our ratio is 6 to 100, and then you may draw the model and shade in 6 of your 100 squares. 60%, on the other hand, is 60 out of 100. So if I write our fraction first, 60 100ths, and I can write the ratio, 60 to 100, we can work backwards and find that 60 100ths should look like that as a decimal. But keep in mind, we could also go directly from the percentage to the decimal, keeping in mind that the last digit in the percentage must be in the hundredths position in your decimal. Our next example in this 600% really puts it to the test. Please remember one more time, the last digit in your percent must fall in the hundredths position in your decimal. So if I put that 0 in the hundredths position and then the next 0 to the left is in the tenths position, that means my decimal point has to be after the 6. Meaning that the decimal for 600% is actually the whole number, 6. Our fraction then, we could write 600 100ths, but that would simplify to 6. And our ratio would be 600 to 100, or 6 to 1. And then finally, when you draw the model, if you don't have any little squares to shade in, you don't need to draw little squares. So 6 squares, separate squares, would represent the number 6. 32%, much easier. Remember, as a decimal, we need the 2 to be in the hundredths position. There it is right there. And 32 100ths is our fraction. And our ratio would be 32 to 100. The last 3 give us some other part rather than just the percent. They give us 55 100ths as the decimal. So having just read the number correctly, I know that that is 55 100ths. And I also know that the ratio is 55 to 100. And I can simplify these, but for this particular lesson, it's not really necessary. And then finally, since we know that it's 55 out of 100, and percent means out of 100, that would be 55%. 9/10 for the next one would be 9 to 10 as the ratio. We also know how to write that as a decimal pretty easily. 9/10 means the 9 must be in the tenths column of that decimal. Keeping in mind that a percent must be out of 100, the easiest way to change that would be to add a 0 in the hundredths position of our decimal. We could also convert our 9/10 fraction into an equivalent fraction that is out of 100. But in order to get my denominator to 100ths, I would need to multiply 10 times 10. And to get the new numerator, I would need to multiply our 9 by 10 as well. Because if you multiply one, the numerator or denominator, you must multiply the other by the same number. And then we can simply write our percent as 90%. The final example has a model of 10 pieces, and 7 of those pieces have been shaded. So as a fraction, that would be 7/10. We can write the ratio easily from that, 7 to 10. And if we are following the same pattern that we looked at in the example above, we would also know that an equivalent ratio to 7/10 would be 70/100. And again, the decimal, we could write 7/10, but just as easily we can turn this into 70/100. And since it's 70 out of 100, 70% will be our percentage. Exercise 5 conveniently also talks about 100 students. Mr. Brown shares with the class that 70% of the students got an A on the English vocabulary quiz. So if Mr. Brown has 100 students, the model that you would need to show is 70 out of 100, which is the number of students who passed the English vocabulary quiz. Finally, we have Marty, who owns a lawn mowing service. He has 100 lawns to mow and 3 people to mow them. 3 people total. Sheila, Marcus, and Luther. You are going to determine your own percentages for each of those 3. They do not have to be equal. However, you need to look at your diagram and make sure that the 3 people are mowing 100% of the lawns. So your percentages are going to need to add up to 100%. And then fill in your fractions and decimals with the equivalents. Please remember, percent means out of 100. Therefore, percents are fractions with a denominator of 100. You can create the models of percents, and one example would be to make a 10 by 10 grid. Each square in that 10 by 10 grid represents 1% or 1/100th.